Hey guys, so this was one of your homework problems. You had a semicircular ring of radius r, and the semicircular ring of radius r carries a linear charge density of lambda. Uh, you need to calculate what will be the field due to this semicircular ring at a point P, and this point P is located in the plane of the ring at a distance of r from the center of the ring over here, right? So if you notice, I've already drawn the diagram, and hopefully this diagram also gives you a hint for how we need to go about solving this problem. There's a reason why it's mentioned that this point P is located r distance away from the center of the rod, right? So we need to calculate the electric field, and this is not a point. I mean, this is not a discrete charge system. It's a continuous charge system. So the idea will still be the same. We'll assume that this is made up of many point charges, and then go about it in the same manner, right? So, so let's start doing this in the same way. We'll assume that this ring is made up of many point charges, right? And let me select one point charges on this ring. So the way we generally select point charges on this ring is at an angle theta. Let me select a small portion which subtends a small angle, d theta. So same method. So let this be my dq. Let this be my dq, right? Okay. But now here we need to calculate what will be the field due to this dq at point P right now, not at the center of the ring, which was the derivation which we had done in class, right? So we need to now calculate what will be the field due to this at this point P over here. So your field due to this dq at this point P would be in this direction, right? And you notice symmetry will be there over here, right? So let me describe this field as d. And we know that if we calculate the field due to all of them, we'll only have an x component of field over here, right? So already giving rise to, I mean, already noticing some points in this case. Okay, but here to calculate what this d will be equal to, we need two things. I mean, to calculate the component of d, we need two things. We need what this angle will be equal to. So let me assume this angle to be equal to some alpha. So if this angle is alpha, even this angle will also be alpha, right? And your x component of field then will be equal to d cos alpha. Okay, so to calculate d then, or basically to calculate the x component of field, we'll say we need d cos alpha. And then the idea is same. I mean, the idea is similar. To get the total field, we'll have to add up all the x components of field over here, right? So this question is a bit mathematical and also a bit geometrical, as in we'll have to make use of some ideas of geometry over here, right? Okay, but proceeding ahead, let's first calculate what the value of d will be equal to. So I'll say d will be equal to k into dq divided by r squared, where r is equal to this distance, right? Okay, so a first geometry point to notice. So first of all, can I say this is a semicircle? This lower portion is a semicircle, and or the upper portion also semicircle. The angle subtended by a semicircle will be a right angle triangle only. So this triangle which I'll be having over here, this triangle which I'll now denote it, this triangle which I'll be having over here will be a right angle triangle, right? And I know that this length will be equal to 2r. This length which we have over here, the diameter is equal to 2r. So since it's a right angle triangle, we can write small r in terms of 2r, and we'll get small r to be equal to nothing but 2r cos alpha. Right. So, and what will dq be equal to? Dq we know will be equal to lambda into rd theta. Substituting both of these values over here, our d value will be equal to k into lambda rd theta divided by 4r squared cos squared alpha. Right? Okay. And then the next thing to notice, I don't need the entire field, I only need the x component of the field. So what will be your x component of the field over here? So your x component of field then will become equal to, so making some simplifications already, this will be equal to k lambda by 4r into cos alpha d theta by cos squared alpha. So this will be equal to k lambda by 4r cos alpha into d theta. So this will be our x component of field right now. And now I need to integrate all these x components of field to get the total field, But you notice I've written alpha here, and the integration should be done with respect to theta. So there's a relation between alpha and theta over here as well. And the relation between alpha and theta over here is, this is your, again, another rule of geometry. That is angle subtended by an arc at the center will be equal to twice of the angle subtended by an arc at any point on the circle, right? So here the relation between theta and alpha is that theta is equal to twice of alpha. From this, we can also get this relation that theta is equal to twice of alpha. So we'll now make use of this to solve our integration. So our total field then our total net field will be equal to summation of all x components of field. And that was equal to nothing but integral of k lambda by 4 r cos alpha into d theta, right? Okay. And now we notice that theta is equal to nothing but twice of alpha. Theta value will be equal to nothing but twice of alpha. So you can either write alpha in terms of theta, or you can write theta in terms of, we can go about this any way we want, right? So let me write this in terms of alpha only. So what will d theta be equal to? We'll get d theta to be equal to twice of d alpha. So this then becomes equal to k lambda by 4r cos alpha, and d theta is nothing but twice of d alpha, right? And now for our limits. So for our limits, what will our values of theta be? To select all the point charges on this ring, your theta value has to vary from 0 to 90 to minus 90, right? So theta value has to vary from minus pi by 2 to plus pi by 2, right? But we have converted this integration in terms of alpha right now, and alpha is nothing but theta by 2. So our limits of theta, our limits of alpha then will be equal to minus pi by 4 to plus pi by 4, right? So our limits integration over here will be equal to from minus pi by 4 to plus pi by 4. Okay, so with this, we can now solve this integration. So taking your constants outside, which is 2k lambda by 4r, which will become equal to nothing but k lambda by 2r. And what we have left with is integral of secant alpha d alpha, with limits being from minus pi by 4 to plus pi by 4, right? This is a straightforward formula right now. Integral secant alpha d alpha is nothing but log of secant alpha plus tan alpha. It is log of secant alpha plus tan alpha, with limits being from minus pi by 4 to plus pi by 4. So substituting the upper limit and lower limit, we'll get k lambda by 2r log of secant of pi by 2, secant of pi by 4 is root 2, tan of pi by 4 is 1, minus log of secant of minus pi by 4 is secant of pi by 4 only, so once again root 2, tan of pi by minus pi by 4 will equal to minus 1. So this becomes equal to k lambda by 2r log of root 2 plus 1 by root 2 minus 1, which after I rationalize this, root 2 plus 1 by root 2 minus 1 will become equal to nothing but k lambda by 2r log of root 2 plus 1 whole squared. So this will be equal to nothing but k lambda by r log of root 2 plus 1, right? So a slightly mathematical question. The approach was straightforward over here, but then how we can actually make use of this approach to get the answer was pretty interesting in this question, right? So hopefully this question made sense. See you guys in the next question. So this will be your answer.